أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Today we will be discussing scientific revolutions theory put forward by Thomas Kuhn, and we'll be looking into cognitive science and also the history of some very basic concepts regarding the scientific method, and also looking at how paradigms shift and how there's constant disagreements within science. And I'll be using Neo-Darwinianism as an example of this. So, Bismillah ar-Rahman ar-Rahim. First off, I will be discussing Kuhn's work here, and I'll read some notes. Bismillah ar-Rahman ar-Rahim. The structure of scientific revolution. History of science, discovery, development, progress, and changes are needed in order to further our understanding, i.e., studying the historical rather than relying entirely on what's taught and shown. Scientific method shown, reinforced by manipulative techniques used to gather textbook data, together with logical operations relate back to data and embolden textbook theoretical generalizations. So this is extremely similar to George Box's paper that we read yesterday. The concept of science stands out with questionable aspects of its natural development. Okay. Presumption is that if science is a network constellation of facts, theories, and methods collected in current texts, then a scientist is someone who successfully or not have striven to contribute to a particular network or constellation and also becomes a contributor within a niche community and seldom interrelated communities. So, to drive this point home, if you are a neuroscientist, there are situations where you become part of a different scientific enterprise, for instance, neuromarketing, behavior economics, consumer behavior, so on and so forth. So these are fascinating interdisciplinary areas that always pop up actually. So, upon such presumptions, Kuhn states that the role of the historian has two main tasks. First is determine the person and period in connection with each contemporary scientific fact, law, theory that was discovered and invented. Number two is describe and explain the disorderly collection of errors, myth, and superstition that have hindered a more speedier process. So I actually across the book Darwinian Black Box, pardon me, Darwin's Black Box by Michael Behe to actually explain this point, which we will step into in a moment. Okay, so moving on from here, it's a pretty straightforward concept Kuhn is trying to put forward here. Okay, next, the process of accumulating constituents of modern scientific text. Third, I will add, is discriminating between bias, judgment, and reason. So this is an extra point that prompted in my mind because there seems to be much scientific bias, right? And what I mean by that is that pro Darwinianists always push the idea of natural selection and random mutation, when in fact, where we'll see in Michael Behe's work, is not always the case. And there's evidence from geneticists, paleontologists, and others to illustrate this point. But connecting this with Kuhn, the whole idea is that just because Darwin said X, Y, Z does not necessitate, it's not necessarily the case that it will be true. And that in that era and right now and beyond. Excuse me. Concept of development by accumulation. What are the right questions to ask? So, for those of you who are involved in business and sales, know that asking the right questions is extremely important. Similar case in science, where the goal is to uncover further what has been demonstrated and what cannot be demonstrated and what might be or ought to be. So, a problem occurs for the historian when confronted with distinguishing between the scientific and the errors of those from the past, including superstitions that filled conversations and books of our predecessors. So, we know for a fact, for instance, that occultism has played a role, a rather surprising role in the past when it comes to science. So, an example of this is Jack Parson, who was one of the early pioneers of rocket technology, right? So, the fact that he states he was in contact with certain spirits and evil entities is no is nothing to be shocked as far as I'm concerned, right? Another contemporary example I can give you is of Peter Thiel, who gives lectures regarding the Antichrist. Supposedly atheist, as far as my knowledge stretches, and the type of statements he gives regarding human civilization. So, historians from, pardon me, historians of the future looking at our era, how will they reconcile all this from a scientific and a historical point of view, and even from a media point of view as well? Kuhn argues that Aristotelian dynamics, phlogistic chemistry, and chloric thermodynamics were simply thoughts of the day, the trend, the theory that rules overall, which now seems out of date, though today's tech and science advancements do originate from individual idiosyncrasies, much like the scientists of the past. If these out of date beliefs are to be called myths, then Kuhn argues that today's science could be said to be a result of mythical knowledge, which we experience today, i.e., awesome and fantastical, right? So this is key. This is key. And it's not a case of painting everyone with the same paintbrush, but there is a plausibility that some concepts have a flavor of mythology within them. On the other hand, if these are to be classified as science, then this science has with it bodies of belief that may seem incompatible with today's science. In simple terms, the criterion and paradigm constantly shifts. Kuhn says the latter is what the historian must choose. But why? Well, just because out of date theories are not in principle unscientific because they have been discarded, but rather there have been a massive paradigm shift. Due to this, it becomes this is because of a massive paradigm shift. Due to this, it becomes difficult and also troublesome to view science as a developmental process that possesses the nature of gradual increase and growth by the addition of new layers and parts and perspectives, i.e., accretion. Accretion or accretion? I always mix up the pronunciation there.
Accretion.
Accretion, yeah. Okay. Right, let me just put this on the screen as well. Page 19 is what I need. Smith. Okay. So what Kuhn is stating here is that it's difficult and troublesome when out of date scientific principles have been kept, or for lack of a better word, remixed with extra layers, with addition of new parts and perspectives, i.e., accretion. Furthermore, challenges arise when individual inventions and discoveries are isolated in order to dissect its history, provides grounds for sowing seeds of doubts regarding the cumulative process through which these individual contributions to science were thought to have been compounded. So, example of this is artificial intelligence. Very few people may know of Turing and Jeff Hinton and Anderson and Alan Newell and Rick Cooper and many other researchers that have played an influential role in cognitive architectures and artificial intelligence and general artificial intelligence. Another notable mention is R.A. Booker as well. So, yes, it's quite a strenuous process, the whole idea of understanding scientific concepts and paradigms and how they turn out to be quite unique, both in nature and function. So Kuhn further states that historians now are shifting their approach from tracing the origins of various cumulative developmental lines and focusing on the permanent contributions of an older science in accordance to our present viewpoints. Historians attempt to display the historical integrity of that science in its own time. The greatest example, the example used by Kuhn is of Galileo. Interest lies not within the comparison of his views to those of modern science, but rather the intergroup relationship between his views and others of his time, teachers, contemporaries, and immediate successors in the sciences. Furthermore, insistence is pursued studying the opinions of that group and other similar ones from the viewpoint usually and often very different from that of modern science. Such opinions maximizes coherence, i.e. comprehensive insight, and the nature of past paradigm. So with these implications, Kuhn states that these historical studies suggest the possibility of a new image of science, i.e. innovative approaches and therefore more chances of error and false histories. Yeah, interesting. So I would like to take a journey back in time, if possible, theoretically possible, theoretically speaking, and we're going to speak about Aristotle. Okay, I have this nice, simple to read text, the Cambridge Companion to Greek and Roman Philosophy, and it gives a brief biography of names of well-known philosophers from the Roman and Greek periods, but also states their contributions. So it's a great read, a elementary text. So the reason I would like to discuss this is simply because as far as historians can trace back, and they claim at the moment, which is widely agreed upon, is that the first individual to put forward a systematic study of arguments and argumentation, which is logic, is Aristotle. And he's the one who has the idea that axioms, so first principles, help us move towards a systematic series of theorems setting out the properties of all the various objects studied by science. So all the theories that exist from first principles, we're going to talk about the theories, and from that point onwards, we'll look at the various objects within that science. So to give a very simple example, if I am looking at the neuroscientific study of the visual system of man, then it would require first principles to be put in place. So first principles would be your evoked potentials, EP, and these are electrical signals that can be measured when a neuron fires and connects with another one. So there's a famous phrase by Hebb, which is neurons that connect together fire together, if I've got that correct. In fact, I think it's incumbent that I verify this. Okay, right. Just give me a moment here. Neurons that wire together fire together. That's the phrase, I believe. Neurons that fire together wire together. That's correct. So neuroplasticity is the backdrop of this. But anyway, so this is a generalized statement. And in order to deduce from this how I can study the visual system of man, I would have to look into Weisel's work with the cat's visual system and how they manipulated light hitting certain parts of the retina, understand optic chiasm, optic radiation, understand the frontal lobe, the occipital lobe, the V1, V2, V3, V4 vision areas, and compare this with non-human primates, okay? And then look at similar studies when it comes to navigation in mice, because visual system is closely linked to the navigation system and of course memory. So with all of this in mind, the Aristotelian approach is that basic truths establish fundamental nature of specific things, and that leads to the study of deriving principles from demonstration or proof that the rest of science can fall back on, essentially, right? So this is on page 133. So I'm going to read from line number 1, 2, 3, 4. Aristotle accepted the mathematical disciplines of arithmetic and geometry as models for all scientific knowledge and understanding, including what we would regard as empirical and experimental sciences such as medicine or biology or physics. Geometry itself presents in the form of rigorous proofs, stating the basic first principle axioms for a systematic series of theorems setting out the properties of all various objects studied by science. So, in this example of geometry, the geometrical figures, triangles, squares, and the like. So, likewise, Aristotle thoughts, each of the other sciences should ideally be presented as starting from a small set of basic truths which establish the fundamental nature of specific kinds of things that the science studies, and deriving from those principles by demonstration or proof the rest of the truths in science, its theorems. So, in his other work, Prior and Posterior Analytics, which is one of the hardest philosophy books I've come across, and inshallah, Allah gives me the intellect to study him. Aristotle studies demonstrative argument in the sciences, ideally so conceived. When and why do conclusions of so this is where Kuhn and Aristotle seem to connect here when it comes to scientific pursuits, which is when and why do the conclusions of scientific arguments actually follow from their premises? What further condition beyond simply having conclusions that follow logically from their premises must arguments in the sciences fulfill? So, what other truths in parallel and what other theorems in tandem, or you could say other crucial texts taken as addendum, can really allow one to begin from a inductive position and move towards a deductive position, and then in inductive position down to the deductive position. So I am now pointing towards George Box's work here now, where he discusses this in his paper that we read yesterday. Okay, so I just found an interesting correlation of thought here. May Allah forgive me if it's completely off the mark. It is in his study of scientific argumentation, page 133, that Aristotle made his most celebrated discovery, his theory of syllogistic. He takes it for granted that every assertion in any of the sciences has the form of subject predicate statement, in which something a predicate is either affirmed or denied of some subject, right? Furthermore, in the sciences, the subjects are always kind of. Furthermore, in the sciences, the subjects are always kinds of thing, rather than individuals. Isosceles triangles rather than the one whose equal sides are 2 inches in length, human beings rather than Socrates or Plato. Even if the sciences do have things to say about individuals, it is about them as members of given kinds, kinds which are, from the scientific point of view, the basic subjects of the predicates in question. Hmm. So any such assertions can be disregarded as derivative from the main business of science, which is concerned with the kinds of universals. With these severely limiting assumptions in place, Aristotle notes that scientific assertions will always be one of four forms. Okay, depending on whether the predicate is affirmed or denied of all the subject or only part of it. Thus, using a convention introduced in the Middle Ages to designate these types of assertion, every scientific assertion will be of one of the following four forms: I, E, I, or O. I illustrate each of these with what is intended to be true, but of course there are plenty of false examples of each as well. So, for instance, number one, A belongs to all, every B. AAB. Every human is two-footed. A belongs to no B. So, example is no fish has feathers. A belongs to some of B. Some lilies are white. A does not belong to some of B. Some lilies are not white. Thus, each of the premises and conclusions Okay. Each of these premises and the conclusions of each and every scientific argument will be one or another of these four forms. Now, in the first chapter of prior analytics, Aristotle defines arguments, which he calls in Greek syllogismoi, singular syllogismos, of which scientific arguments are, according to him, a special case as follows. A syllogismos is an argument in which certain things being posited, something else different from the thing posited results of necessary of their being so. Right? So this is the case where certain things are put forward, sky is blue, for example, something else different from the thing is posited results of necessary because of their being so. So the sky is blue, and blue is one of the spectrums of white light. So the sky is not white because of a scientific phenomena that emits blue light everywhere. Okay, so all of these things are true. Sky is blue, blue light is filtered out from the white light due to the spectrum that the white light possesses. Okay, thus a syllogismos is in modern terminology a deductively valid argument, i.e., one such that if or where whenever its premises are true, the conclusion necessarily must be true as well. So that's what I was mentioning earlier, right? And what we spoke about yesterday concerning George Box's perspective of deductive and inductive approaches and feedback loop. And moreover, one of a particular kind, namely one where the conclusion is different from its premise or premises. And they've given me a reference here, which I'm intrigued to know what that is. Okay. For good reasons, it is fundamental to modern systems of mathematical logic that an argument from any proposition as premise to that same proposition as conclusion is treated as valid. Such an argument does not count for Aristotle as syllogismos. Nothing is collected or calculated together, which is the ordinary meaning of the verb from which the Greek noun derives in reaching such a conclusion. Right, I see. Okay, interesting. Hmm. Our word syllogism was in fact adopted into English simply as a transliteration of Aristotle's syllogismos, yet it is always used in such a way that there are both valid and invalid syllogisms, i.e., valid and invalid arguments of a certain determinate form. So, paradoxically, it is desirable in discussing Aristotle's syllogistic not to use syllogism to translate his Greek. Instead, it is better to speak of the intended subject of the definition I just quoted as valid deduction. Certain type of a certain type, i.e., ones where the conclusion is distinct from any of the premises. Now it is evident that, with some obvious exceptions, no single proposition of any of the forms A, E, I, or O can logically imply any other different proposition of any of those forms. But of course, again, with this part here, reference 9. So, yeah, So there are exceptions, even though premises can be changed. So inverted, sorry. So for example, A EB implies that BEA. So that means, for example, that no dogs or horses implies that no dogs or horses. BIA and AIB, that some dogs are females, implies that some females are dogs. And BAA implies AIB, that all dogs are animals, implies that some animals are dogs. Aristotle recognizes and makes separate use of these exceptions under the rules of conversion, which he uses in his proofs of validity of inferences in the three figures. Right? So the three figures are something that is discussed in detail here, but for the sake of this current lecture today, we're just going to focus on the idea of syllogisms and deductive inductive arguments. Okay, so I think at this point it's okay if we now stop here and very briefly speak about how certain paradigms have been certain paradigms shift, right? Inshallah, they will. Self belief is powerful. Right, so what I like to do is just discuss chapter 2 of Darwin's Black Box, and this will give you an idea of how paradigms shift as time goes on, and methodologies are challenged, and even systems are altered and changed, right? So, Assalamu alaikum, bro. Just send me a Instagram message and I will reply, inshallah. Jazakallah khair. So, Michael Behe opens up by essentially challenging neo-Darwinism, and he quotes Lynn Margulis. Lynn Margulis, she's famous for putting forward the widely accepted theory for the energy source of mitochondria, and quote, and I'm quoting here. Lynn Margulis says that history will ultimately judge neo-Darwinism as a minor 20th century religious sect with the sprawling religious persuasions of Anglo-Saxon biology. So this, in a sense, takes the shift in paradigm and a criterion as being underscored, which is mythology. Now, her saying this doesn't mean it's true, obviously, but there seems to be a cultish like behavior. Okay, so at one of her many public talks, she asks molecular biologists in the audience to name a single unambiguous example of the formation of a new species of accumulation of mutations, right? So, mutation is the idea where systems come together to form a new system. And famous concept that's being pushed by Darwinism is random mutation. So randomly things mutate and create complex systems, which sounds fantastical to say the least. Her challenge goes unmet. Proponents of the standard theory say, she says, wallow in the zoological capitalistic competitive cost benefit interpretation of Darwin, having mistaken him. Neo Darwinism, which insists on the slow accrual of mutation, is in a complete funk. So, how can you justify and describe time having being the driving factor here? It's extremely difficult to understand this and concretize this, as far as I've understood so far. So, 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 Right. In the 1940s, geneticist, this is page 26. In the 1940s, geneticist Richard Goldschmidt became so disenchanted with Darwinism's explanation for the origins of new structures that he was driven to propose the hopeful monster theory. Goldschmidt thought that occasionally large coordinated changes might occur just by chance. Perhaps a reptile laid an egg once, say, and from it hatched a bird. The hopeful monster theory didn't catch on, but dissatisfaction with a Darwinian interpretation of the fossil record bubbled up several decades later. Paleontologist named Niles Eldridge describes the problem. So now we're going to get perspective here. No wonder paleontologists shield away from from evolution for so long. It never seems to happen. Assiduous collecting up cliffs, cliff faces yield zigzags, minor oscillations, and the very occasional slight accumulation of change over millions of years at a rate too slow to account for all the pardon me, a rate too slow to account for all the prodigious change that has occurred in evolutionary history. When we do see the introduction of evolutionary novelty, it usually shows up with a bang, and often with no firm evidence that the fossils did not evolve elsewhere. Evolution cannot forever be going on somewhere else, yet that's how the fossil record has struck many of forlorn paleontologists looking to learn something about evolution. So it's inconclusive in simpler terms. Now, to alleviate the dilemma, in the early 70s, Eldridge and Stephen Jay Gould, another famous, I believe he's a biologist, evolutionary biologist, or a paleontologist, proposed a theory they call punctual equilibrium. So the theory postulates two things. The theory postulates two things that for long periods, most species undergo little observable change, and that when it does occur, change is rapid and concentrated in small, isolated populations. Very hard to prove this. If this happened, if, again, this is conditional, then fossil intermediates would be hard to find, squaring with spotty fossil records. Like Goldschmidt, Aldrich, and Gould believe in common descent, but think that a mechanism other than natural selection is needed to explain rapid large scale changes. So you can already see interesting paradigms being worked around here. In fact, maybe Kuhn speaks about this, I believe. '77, '79. Yeah. I mean, he has a section on falsification, but I'm just thinking it's not really going to be relevant for today's lecture here. I mean, if I speak about falsification, then we need to discuss Karl Popper's view on the falsification of scientific method. So yeah, we'll stick with this for now. So yeah, jumping back to Michael Behe's work here. Yeah, punctual equilibrium, new theory, bit of panic in the paleontology departments. Anyway, Gould has been at the forefront of the discussion of another fascinating phenomenon, the Cambrian explosion. Careful searches show only a smattering of fossil and multicellular creatures in rocks older than 600 million years. Yet in rocks just a little bit younger is seen a profusion of fossilized animals with a host of widely differing body plans. Recently, the estimated time over which the explosion took place has been revised downward from 50 million years to 10 million years, a blink of an eye in geological terms. So, yeah, this is quite interesting how there's been a shift. Again, it's just Kuhn was way ahead of his time, so I'm not surprised his work was one of the most cited. One. The shorter time estimate has forced headline writers to grope for new superlatives, a favorite being the biological Big Bang. So Gould has argued that the rapid rate of appearance of new life forms demands a mechanism other than natural selection for its explanation. Ironically, we have come full circle from Darwin's day. When Darwin first proposed his theory, a big difficulty was the estimated age of the Earth. 19th century physicists thought the Earth was only about 100 million years old, yet Darwin thought natural selection would require much more time to produce life. Key point here. At first, he was proven right. The Earth is now known to be much older. With the discovery of the biological Big Bang, however, the window of time for life to go from simple to complex has shrunk to much less than 19th century estimates of the Earth's age. It is not just paleontologists looking for bones, though, who are disgruntled. A raft of evolutionary biologists examining whole organisms wonder just how Darwinism can account for their observations. The English biologist May Wan Ho and Peter Saunders complain as follows. Now, this is an interesting example they give of moths. Okay, and the reference here is number 5. So, number 5. This is from Ho and Saunders, 1979, Beyond Neo-Darwinism, an epigenetic approach to evolution. Sounds like a fascinating paper we can add to the list of papers that will be approached at some point. It is now approximately half a century since the Neo-Darwinian synthesis has formulated. A great deal of research has been carried on within the paradigm it defines, yet the successes of the theory are limited to the minutiae of evolution, such as the adaptive change in coloration of moths. While it is remarkably little to say on the question which interests us most, such as how they came to be moths in the first place. So, how did moths come in the first place? A very complex creature. And is it the Jubilee or I think the Jubilee butterfly that springs to my mind? And the Nahla and the bee as well, how complicated it is. And stating that this is all just an evolutionary process, I think is a disservice. And it's really a cop out from atheists who are staunch disbelievers of Allah. So it's fascinating perspective from them. Furthermore, geneticist John MacDonald notes a conundrum. The results of the last 20 years of research on the genetic basis of adaptation has led us to a great Darwinian paradox. Those genes that are obviously variable within natural populations do not seem to lie at the basis of many major adaptive changes, while those genes that seemingly do constitute the foundation of many, if not most, major adaptive changes apparently are not variable within natural populations. Evolutionary geneticist George Miklos puzzles over the usefulness of Darwinism. What does what then does this all-encompassing theory of evolution predict? Given a handful of postulates, such as random mutations and selection coefficients, it will predict changes in gene frequencies over time. Is this what a grand theory of evolution ought to be? So what he's stating here, paper is emergence of organizational complexities during metazoan evolution, perspectives from molecular biology, paleontology, neo-Darwinism. So there is variability in genes, and it can't be explained from a neo-Darwinian paradigm. So it's just time. Going back to George Milco's thing, is this what the overall theory is? Just taking time as a precursor to everything. Interesting. Jerry Coyne, Department of Ecology and Evolution at the University of Chicago, arrives at an unanticipated verdict. We conclude unexpectedly that there is little evidence for the Darwinian view. Its theoretical foundations and experimental evidence supporting it are weak. This is from a reference here. Coyne or the Genetics of Adaptation, a reassessment. Okay, interesting. And University of California geneticist John Endler ponders how beneficial mutations arise. Although much is known about mutation, it is still largely a black box relative to evolution. Novel biochemical functions seem to be rare in evolution, and the basis for their origin is virtually unknown. This is from the process of evolution toward a newer synthesis. So this is a vast field in of itself, of course. So again, I'm just going to give a few more points here. Next is Hubert Yoki, information theorist. He states that the information needed to begin life will not have developed by chance. He suggests that life be considered a given, like matter or energy. In 1966, leading mathematicians and evolutionary biologists held a symposium at the Wistar Institute in Philadelphia because the organizer, Martin Kaplan, had overheard a rather weird discussion between four mathematicians on mathematical doubts concerning the Darwinian theory of evolution. At the symposium, one side was unhappy and the other was uncomprehending. A mathematician who claimed that there was insufficient time for the number of mutations apparently needed to make an eye was told by the biologist that his figures must be wrong. The mathematicians though were not persuaded that the fault was theirs. As one said, there is considerable gap in the neo-Darwinian theory of evolution, and we believe this gap to be of such nature that it cannot be bridged with current conception of biology. So it's extremely limited and to some degree nullified. So this is Schutzenberger, Algorithms and the Neo-Darwinian Theory of Evolution, Mathematical Challenges to the Neo-Darwinian Interpretation of Evolution, Moorhead Kaplan Wistar Institute. Alright, interesting. Stuart Kaufman, who has a book I have here titled The Origins of Order, is quoted here. Santa Fe, leading proponent of complexity theory. Simply put, it proposes that many features of living systems are the result of self-organization, the tendency of complex systems to organize themselves in patterns and not natural selection. So, complexity theory, maybe what I can find will relate to what we're discussing today. So let me see whether complexity so many value. I think not. Hmm. Yeah, I think it's not relevant for today. Right. So simply put, complexity theory. It proposes that many features of living systems are the result of self organization, the tendency of complex systems to arrange themselves in patterns and not natural selections. Quote Darwin and evolution stand astride us, wherever the mutterings of creation scientists. But is this view right? Better, is it adequate? I believe it is not. It is not that Darwin is wrong, but that he got hold of only part of the truth. The partial truths are at play, according to Hoffman. Complexity theory has attracted few followers, but much criticism. John Maynard Smith, under whom Kaufman did graduate work, complains that the theory is too mathematical and is unconnected to real life chemistry. Although the complaint has merit, Smith offers no solution to the problem which Kaufman identified, the origin of complex systems. All told, Darwin's theory has generated dissent from the time it was published, and not just for theological reasons. Hmm. 1971, one of Darwin's critics, St. George Mivart, listed his objections to the theory, many of which are surprisingly similar to those raised by modern critics. And then it goes on from here. This is the last point I'd like to mention. Before going further, we should note the obvious. If a poll were taken of all scientists in the world, the great majority would say they believe Darwinism to be true. Well, scientists, like everyone else, base most of their opinions on the word of people. Testimony, possibly being one of them. Of the great majority who accept Darwinism, most, though not all, do so based on authority also, and unfortunately, too often criticism have been dismissed by the scientific community for fear of giving ammunition to creationists. It is ironic that in the name of protecting science, trenchant scientific criticism on natural selection has been brushed aside. So yeah, this goes back to actually the point I mentioned concerning Kuhn, which is that they were discriminating between bias and judgment when Kuhn is speaking about the presumptions that exist. So again, I think this agrees with my point. I'm not trying to say that I am contesting or updating Kuhn's paradigm at the moment, but there seems to be biases that exist, and yeah, this must be highlighted. So from here, Michael B. he gives an example of beetle bombs and the heated liquid that they excrete when defending themselves. So this is a demonstration, right? Which is in connection with Aristotle when he talks about demonstration is important when working from first principle. So yeah, that's that. So we're now going to look at an interesting text here that I came across when looking into Kuhn's scientific revolutions. And in fact, I got this from Stanford's own philosophy website. Okay. So, book is titled here The Cognitive Structure of Scientific Revolutions. This is an interesting title. Kuhn's theory of concepts. So, we're going to read through this, see what they have to say. Now, I'm quite intrigued to learn a bit more here. So, this is page 19. After the appearance of the structure of scientific revolutions in 1962, Kuhn attempted to develop a Wittgensteinian account of family resemblance concepts for a domain that other philosophers had found most unlikely: scientific concepts. In the 70s postscript structure, Kuhn even suggested that the variants of Newton's second law that applied to different physical systems showed family resemblance but no single defining properties. If this proved to be the general case, the most important example of scientific concepts might turn out to be family resemblance concepts rather than the well behaved concepts analyzable by necessary and sufficient conditions expected by earlier philosophers of science. Kuhn returned to these themes again and again in his later philosophical writings. Kuhn's theory of concepts focused on a restricted class of terms, namely kind terms. Kuhn defined kind terms. They are primarily the count nouns together with the mass nouns, words which combine with count nouns in phrases that take the indefinite article. Some terms require still further test hinging, for example, on permissible suffixes. Thus, kind terms include natural kinds, artifactual kinds, and social kinds. So it's talking about kind. So when someone says what kind of approach, what kind of model, what kind of testing, and so on. Exemplars. An important source for Kuhn's theory of concepts was his early reflection upon science teaching. Made an observation that first, science education is based entirely on prepared teaching material, and second, teaching confers ability to recognize resemblances between novel problems and problems that have been solved before. Yep, I agree there. This ability seems to rely almost exclusively on exemplary problems and concrete solutions rather than on abstract descriptions and definitions. Textbooks do not describe the sort of problem that the discipline deals with in the abstract, but exhibit concrete problem solutions that the profession has come to accept as paradigms, and they ask the student either with pencil or paper or in the lab to solve for himself problems very closely related in both method and substance to those through which the textbook or the accompanying lecture has led him. Within linguistic Within linguistics, the term paradigm is used to denote conjugation patterns, such as pattern displayed by the Latin verb amo, amas, amath, amamus, amathis, amant. Kuhn claimed that the procedure by which science students are supposed to model novel problems on exemplary problems is similar to the procedure by which language students learn conjugations by extracting patterns from examples. He adopted the term paradigm to denote standard examples in science teaching. Thus, the term first entered Kuhn's work prior to the publication to denote standard scientific problems or exemplars used in teaching. Interesting. Kuhn was making a general claim about the whole of scientific practice when he maintained that the link between research problems within a given discipline is not that they satisfy some explicit or even some fully discoverable set of rules and assumptions that gives the tradition its character and hold upon the scientific mind. Instead, they may relate by resemblance and by modeling to one or another part of the scientific corpus which the community in question already recognized as among its established achievements. Kuhn adopted Wittgenstein's notion of family resemblance concepts, suggesting that research based on exemplars may share a family resemblance rather than being related by specific rules of methodology. This became clear in the 70s postscript, in which Kuhn suggested that the variants of Newton's second law applicable to different physical systems share family resemblance, but no single defining common property. Here, Kuhn pointed out the basic form of Newton's second law. So here's an example that he gives. F is equal to mass and accept times acceleration. Transforms into different but similar forms of different kinds of problem situations. For example, free fall. M times G. M is displacement squared S over dt squared, distance times squared. Single pendulum sine theta of mg gravity is equal to negative ml mass ml distance squared theta over d. Interacting harmonic oscillators. This example, using a fundamental principle of classical mechanics, suggested that the most important instances of scientific concepts might turn out to be family resemblance concepts rather than concepts definable by necessary and sufficient conditions as expected in the philosophical tradition. Subsequently, Gier has vindicated Kuhn's controversial claim with a detailed analysis of the family resemblance structure of classical mechanical models. Similarity, dissimilarity in kind hierarchy. Hmm. This book is going in various directions here. Mm, we'll talk about it. Anderson, I believe Anderson is a cognitive architecture researcher. Let me double check this. Anderson, Virginia, Institute of Concepts, Correlation, Right, let me go to bookmarks. Yeah, so now we're slowly diving into connectionism here to a degree. So we'll discuss connectionism tomorrow. So yeah. Okay, right. So I think I've touched on some interesting concepts. To 90 approaches and find causal states. Murphy many chapter 4, scientific change, the phase, came to describe. Hmm. On screen, webbed, partial frame representation, taxonomy, core concepts in the 30s, attribute value, blah blah blah. Okay, so one section I found which was pretty interesting and relevant actually is here. Mm, Go here a second. Scientific change, right? So, phase of scientific development. Let's just jump straight into this here. Structure of scientific revolution. Kuhn claimed to have described in a preliminary way a pattern of development that could be found throughout science and throughout science history. He uses historical examples ranging from ancient astronomy and optics to physics in the 20th century. But from the viewpoint of the historian, it is dramatically implausible to suggest that the usual factors considered in historical explanation were sufficiently constant over all periods considered by Kuhn to yield similar structures of one. Yes, I absolutely agree here because Rupert Sheldrake, in a interesting table discussion from the 90s with Oliver Sacks and also with a couple of other philosophers and Dan Dennett, Epstein's lapdog, they talk about evolution, I believe, if I'm not mistaken. And Rupert Sheldrake brings up a similar point. He said you have to assume all factors are constant and the environment was perfect at all times. So between the ancient period and the 20th century, the institutional structure of science, its relation to the wider culture, education, social class, career paths of scientists themselves, changed not once but several times, despite his insistence that the scientific community is the main actor in his account. Kuhn was adamant that such factors played little role in intellectual changes that were his primary concern. Right, so Kuhn was not really concerned with this. Interesting. Rejecting the usual historical factors, a second possibility to justify the appearance of similar structures in different disciplines and different periods might be the cognitive structures that now have been demonstrated by psychologists and cognitive scientists to be universal features of human intellectual activity. Now, this is now delving in my area. On this basis, the division between normal and revolutionary science can be understood as the distinction between research conducted in terms of an existing conceptual structure without changing that structure, and research proceeding by modifying an existing conceptual structure. So, an example I can give you is executive function and many tests that are used. One of the ones that I've been working on recently is understanding temporal errors when it comes to set loss sensitivity and in executive functions during the Wisconsin card sorting task. Simpler words, can we track at which point an error is made? And there's various categories of errors that we we compartmentalize, but they are instrumental, obviously. So yeah, it's absolutely correct. There's a distinction between research conducted in terms of existing conceptual structure without changing the structure, and research proceeding by modifying an existing conceptual structure. So yeah, in principle, we should not see the division as corresponding to a linear sequence of historical changes. With normal science succeeded by a revolutionary science, succeeded by normal science indefinitely. Both patterns of research may coexist, of course. Likewise, we do not suggest that the division applies only to revolutions that involve major modifications of conceptual structures. Instead, the division implies that revolutions may vary in scope and severity from mini revolutions created by modifications of minor parts of the conceptual structure to major revolutions created by fundamental modifications affecting large parts of the conceptual structure. So, in other words, there's the subsystem has a subsystem, as George Box states. So, there are revolutions that vary, rightly so, here in scope and severity. So, I have no issues with that so far. I think now we're getting somewhere with this text. Hierarchical principles of stable conceptual structures explained in section 2.3. Concepts formed by family resemblance tied together in contrast sets that form kind of hierarchies. The formation of kind hierarchies by breaking up a class into established part of logic. Principle of no overlap, principle of social and principle. Hmm. Right, so different principles are being discussed. Yeah, why not? Let's look into it. So, usually the logical division is characterized by three principles: the principle of no overlap, principle of exhaustion, and principle of inclusion. Although we will subsequently express reservations about the extent to which these principles are distinguishable logically independent when applied to actual historical cases, some version of these principles has been taken as fundamental for any hierarchy of kinds, and violations of the principles therefore indicate that something is wrong with a hierarchical structure. According to the no overlap principle, the division in a kind of hierarchy is exclusive. No concepts in a contrast set formed by division of a superordinate are allowed to overlap. The periodic table of the elements, for instance, is such an exclusive division. No atom can be both iron and carbon. Likewise, for astronomers in the 16th century, there are no fixed stars that are planets, no celestial objects that are also sublunar objects. The no overlap principle is violated by objects. The no overlap principle is violated by objects that cannot be classified in this way. If an object is encountered that, judged from some feature, has to be an instance of one concept, but judged from other features has to be an instance of another concept in the same contrast set, the object is an anomaly. We shall return to historical examples of this. Interesting. So now features lead to an object being anonymous. Sorry, an anomaly. According to the exhaustion principle, A division of a subordinate concept never leaves any residual instances. That is, the extension of all concepts in a contrast set together exhausts the extension of their subordinate. So you have a concept and then a contrast, and then each one exhausts the opposite. Okay. So from a chemistry textbook, we can learn the full contrast set of natural occurring elements. Contrast set will be exclusive in the sense that we do not accept to find an element that does not belong to any of the existing 92 categories from hydrogen to uranium, but also occurs naturally. Likewise, astronomers in the 16th century knew that celestial objects were either fixed stars or planets with individual notions, a category that included the sun and the moon. They did not expect to find anything that did not belong to one of these categories but could still be counted as a celestial object. This principle can be violated if an object is encountered that judged from some features clearly belong to a given contrast set, but that judged from features usually differentiating the contrasting concepts in the set cannot be an instance of any of these concepts. So why can it be violated? This principle can be violated if an object is encountered that judge from some features clearly belong to a given. That's not, can't really understand this. How can it be violated if it's contrast sets? Okay, let's check this. The exhaustion principle dictates that dividing a subordinate concept into a contrast set leaves no residual instances as the combined extension of the subconcept entirely cover the parent concept. This rule implies that a defined set such as the 92 natural chemical elements accounts for all possibilities within its domain, leaving nothing outside of these defined categories. The principle is violated when an object is found that clearly belongs to the superordinate category but cannot be classified in any of the existing contrasting. So give example of a violation where an object satisfies the superordinate category and its features are in features are not in agreement, features are valid in said category, yet violate this principle as a subcategory, as a sub-concept differs from the main concept and also do the features determine the violation or do the functions of the object or its very nature also give easy examples. Okay, I understand what's going on. To understand exhaustion in vanity, it helps to look at a simple real world example where object fits the big group. superordinate but breaks the rules of the subgroup contrast set. Right, so contrast is not opposite, it's shades of other. Okay. Simple example of violation. When European scientists first encountered the platypus in 1799, it completely violated their existing classification system. Subordinate concept is a big group where terrestrial vertebrates were land animals with backbone. Contrast set subgroups. Scientists believe that big group was exhausted by two subgroups: males, which give birth to live young and have fur, and birds, reptiles, which lay eggs and do not have fur. So there's a commonality. Both give birth, but mammals have fur and birds have feathers. Wow, this is similar to Aristotelian syllogism, I think. They did not expect to find any animal outside these categories. What so the violation, the platypus clearly belonged to the big group of land vertebrates, however, it had fur and produced milk like a mammal, but it laid eggs and had a duck-like bill. Because it had features from both subgroups, it could not cleanly fit into either one. It was a residual instance, something left over that proved the existing subgroups did not cover everything. So it's an emergence of something new. What determines violation? Feature functions of nature. In philosophy and linguistics, a violation is determined by features, but those features must represent the essential nature of the objects, not just the superficial functions. Here's a breakdown of how they interact. Features determine the classification. So the text states that a violation happens when an object features usually differentiate the subgroup, but this new object mixes or breaks out those features. Example 1, if a shape has four sides, it fits subordinate group polygon. If your subgroups are square, four equal sides, and rectangle unequal sides, both are four, a shape with three equal sides and one wavy side violates subgroup based on its physical features. Okay, that's nice and simple. Nature trumps function. An object's function, what it does, rarely determines a violation because different things can do the same job. Instead, its fundamental nature, what it actually is what causes the conflict. For example, think of a superordinate category vehicles. For a long time, subgroups were land vehicles and aircraft. So a flying car or a hovercraft violates this, or a FTOL, right? Those electric air vehicles. Its function is just transportation, which fits the main concept, but its nature and structural features allow it to both drive on road and fly in the air, shattering the boundaries between subgroups. Two easy everyday examples: a spork, subordinate handheld eating utensils. Contrast set, forks for stabbing food, spoon for scooping liquid. Historically, people assumed these two categories exhausted the options. The violation of spork, it belongs to the main group of utensils, however, because it has tines to stab and a bowl to scoop, if its features violate the strict separations between a fork and a spoon. Right, but if satisfies the subordinate, which is handheld eating utensils. Example 2, portable communication tool. Contrast set, mobile phones for call texting, computer PDAs for internet email. The violation, early iPhone smartphones, it was undeniably a portable communication tool, yet its nature and features merged a computer operating system with a cellular radio. Could not be classified strictly as a phone or a computer, forcing the creation of a new category. Right, that makes more sense. Now let's look at this one here. Thanks. Now do the same with the no overlap principle, a cornerstone of classification system like periodic table, dictates that subgroups within a hierarchy are mutually exclusive, meaning no object can belong to more than one category simultaneously. Violations occur when objects such as a double agent in a scientific or conceptual hierarchy exhibits features that force it into multiple supposedly distinct categories. This contradiction between expected classification and actual dual-natured characteristics results in a fundamental anomaly that challenges the structure of the system itself. Okay, so if an object fulfills the criterion of being part of the superordinate, however, exhibits behavior or brings forth features that shift it in part or later as a whole into a subcategory, would this mean it would the leave the superordinate and therefore be considered a new object, or would it be the case where the features would need to go through a re-evaluation due to a in this violation of this principle, and thus birthing a need for a new method of research slash testing and a model that now must be workable for new anomalies that may arise. Give easy examples. And am I on the right track here? Let's see what it says. Well, alhamdulillah, you are. Yes! I love it when Gemini puts bold. And gives a bit of an ego boost. Yes, you are absolutely on the right track. You have hit upon the exact mechanism of how science and language evolve when faced with anomalies. To answer your core question, the object does not leave the subordinate category, but it still possesses the core defining traits of the big group. It stays inside it. Instead, the features and the system itself must undergo a massive reevaluation. The existing model breaks, forcing researchers to invent new testing methods, new rules, and more adaptable models to accommodate future anomalies. Here's a breakdown of why this happens, followed by easy examples. Why the object stays but the model changes. When an object violates the no overlap or exhaustion principles, creates a crisis for the existing system. Number one, it cannot leave the superordinate. The object is fundamentally a part of the big group. For example, a weird new animal is still undeniably an animal. You cannot just expel it from biology. The crisis of features. The problem isn't the object, it's our definition of subcategories. The features we thought were mutually exclusive, like only birds lay eggs and only mammals have fur, turn out to be overlapping. The birth of new models. This forces scientists to abandon the old rigid way of sorting and developing a new workable model, what philosopher Kuhn calls a paradigm shift. Exactly what I've been talking about. They must create a new criteria that can handle this anomaly and others like it. Easy examples of this reevaluation: the light dilemma, physics. This is the ultimate historical example of what you described. Subordinate category, physical phenomena and entities in the universe. So the old subcategories no overlap. Waves are continuous energy like ripples in water, and particles, discrete bullets of matter like marbles. Centuries physics dictated that something could not be both. Anomaly, however, is that experiments showed light behaves like a wave in some setups, bending around corners, but behaves like a particle in others, knocking electrons off metal. Yep, quantum biology is where I came across this concept first by Jim Khalili. The re-evaluation. Right, so light did not leave the universe or become a non-physical entity. Instead, physics had to go through a total revolution. Scientists had to invent quantum mechanics, a brand new model and method of testing which accepts wave particle duality as a fundamental rule for new anomalies. Biology, viruses, subordinate category, structures made of organic matter, living things, cells that metabolize and reproduce on their own, and non living things, inert chemicals and crystals. The anomaly is the virus. Outside a host, it is completely inert and crystallizes like a chemical, non living thing. Inside a host, it takes over cells and reproduces, living. Interesting. The reevaluation. Viruses are not expelled from organic science. Instead, biologists had to re-evaluate what life means. They had to shift from a rigid binary model to a gradient model, creating new research methods to study things that exist on the literal threshold of life. Tomatoes, culinary and botanical, everyday example of classification systems fracturing based on context. Subordinate category of plants, plant parts we eat. So old subcategories where there's no overlap: vegetables, savory, used in main meals, and fruits, sweet, contain seeds, and eaten as a dessert. The anomaly, the tomato, functionally and colly, it behaves like a vegetable. Scientifically and structurally, it develops from a flower and contains seeds. The reevaluation here is rather than kicking the tomato out of the food category, the anomaly forced a separation of morals. We now have a botanical model where it is strictly a fruit and a culinary legal model where it's classified as a vegetable for trade and cooking. Wow, interesting. You are completely right, Tanks. Anomalies do not break the object, they break the system. The presence of a violating object triggers a re evaluation of features which birth modern quantum physics, evolution biology, and advanced chemistry. Right. So, can you give me a can you very briefly give me an example from neuroscience and cognitive neuroscience and connectionism connectionism school of thought as recent as 2026? Recent research in cognitive neuroscience, connectionism school of thought, which models mind using artificial neurons, has triggered a major paradigm shift. Hmm. For decades, neuroscience relied on a strict no overlap principle regarding how the brain processes information. Category A is single cell encoding. Individual neurons act as symbols or specialists, firing only for a specific concept, like a banana neuron. Category B, distributed representations. Concepts are stored across a vast shared network of multiple neurons firing together. 2026 anomaly, mixed selectivity and neural manifolds. So recent studies published in journals like Philosophy and Mind Science have highlighted a mass violation of this neat non-overlapping classification. Wow, I did not know that. When tracking neural activity using deep learning models, the core tool of modern connectionism, when tracking neural activity using deep learning models, core tool of modern connectionism, researchers found that individual neurons do not belong to just one category. Instead, they exhibit mixed selectivity. A single neuron might fire for color, spatial location, and short term memory all at once, constantly multiplexing and shifting its behavior depending on the context. Now, the re-evaluation and new model. Because this completely shattered the old one neuron, one message encoding model, cognitive neuroscience did not abandon the superordinate category of neural representation. Instead, as you predicted, the field is undergoing a total re-evaluation. Man's predicting science, bro. Connectionists and neuroscientists have shifted to a brand new model. Neural manifolds and latent spaces. Interesting. Instead of looking at individual rigid categories of neurons, scientists now map the geometry of the population's activity as a whole. This new framework treats the brain not as a collection of static files, but as a dynamic mathematical landscape where functions overlap. Would you like to explore the shift to neural manipulation? Wow, yes, I would like to explore that. But I have one last principle to cover, and then this will be the end. Oh no, there's two more. Right, let's get to it. Thanks. Now, again, very briefly, for this is exhaustion principle. So you had the exhaustion principle, which states that a set of concepts should fully cover a superordinate category. It's violated when an instance fits the broader category but none of the subcategories. An example is the emergence of liquid neural networks, which are intelligent systems that fit neither traditional symbolic processing nor standard connectionist pattern-based approaches. The anomaly forces a re-evaluation of existing models to accommodate new unanticipated types of cognitive systems. So no overlap and exhaustion seem to be similar. Very briefly, what are the key differentiating aspects of the no overlap and exhaustion principle, as they both sound markedly similar? So, for example, if an object, okay, that has been shown to satisfy, complement, enhance, and abide by a scientific law X. However, there come a time whereby the object may cause a rift, division, challenge, may cause on opposition theoretically or pragmatically to said law X. Does that mean the law X is tested again and again in order to determine the object's features and functions due to this subcategory violation, or is it simply a simply a question of reorganizing knowledge obtained from the past regarding law X and what the new data slash studies show? Am I on the right track? And give very simple examples Yes, you're on the right track again. You are precisely describing how science progresses when law meets an exception. Here is the quick breakdown of the difference between the two principles, followed by how science handles the violation of the law. Core differences. In one sentence, no overlap principle says an object cannot belong to two categories at once. Double agent. Exhaustion principle says there are no categories missing from the list. A violation is ghost, completely new thing, like gas that was left off the list entirely. Okay, so one is saying you can't belong to two categories at the same time. Second is saying that so no missing categories. So the taxonomy, in a way, has to be precise, watertight. How science handles a violation of law X. When an object suddenly opposes a trusted law, science does both things you mentioned, usually in a two-step sequence. Step 1, test and isolate the object. First, scientists relentlessly test the object to see if it's a fluke, error, or if its hidden features, functions, causes the violation. Step 2, reorganize and revalue the law. Once the object is proven real, scientists reorganize past knowledge. They do not throw law X away, they change its boundaries. Key. Law X is downgraded from universal law to special case law that only works under specific conditions. Okay, this is a nice new thing I've learned. So from universal law downgrades to special case law. An example, Newton's law of gravity versus Mercury. Newton's law of gravity perfectly predicted the movement of almost every planet for centuries. Opposition as telescopes improved, scientists noticed that the planet Mercury is moving in a way that slightly broke Newton's law. Process. First, they looked for error or hidden features. They even hunted for a hidden planet called Vulcan that might be pulling on Mercury. When that failed, Einstein reorganized past knowledge with relativity. Newton's law wasn't completely wrong. It only worked for slow moving, normal sized objects. So, this is very similar to neo Darwinism, which we've been speaking about so far. Another simple example, water contracting when cooled. Trusted law X, thermal expansion states that all matter expands when heated and contracts when cooled. Opposition, when you cool water down near to the freezing point, 40 degrees to zero, suddenly does the exact opposite, it expands. This The process, scientists tested water molecule features and found its unique hydrogen bonds created a crystal cage when freezing. They did not throw out the law of thermal expansion, they reorganized knowledge to state the law applies to most matter except fluids with specific geometric molecular bonds. So you can see the subcategories and the subcategories within them were obviously changed. Would you like to explore quantum computing currently forcing this kind of reorganization? Standard. Okay. Last but not least, we are going to do this. Thanks. Let's see if I can get a hat trick here. Okay. Inclusion principle states that anything belonging to a lower level category as subordinate must automatically inherit all the rules and traits of the higher level category as superordinate. For example, if all birds lay eggs, then a duck must lay eggs. Okay. When the principle is violated, it usually collapses into violation. of no overlap or exhaustion. Principles at a high level, meaning it is rarely a standalone error. Simple everyday example, fruits must contain seeds. Subordinate category are bananas. So commercial seedless bananas. They are undeniably bananas because they fulfill the super superordinate category fruit. But they do not have seeds, the mandatory superordinate trait. So where does the collapse happen? This forces us to either accept that a fruit can be a non-fruit, so no overlap violation, so can't be two categories at the same time, or our definition of plant categories is missing a group for sterile produce. So a missing category. Right. Neuroscience connectionism example 2026 perspective. So, superordinate category, deep neural networks must use back propagation and gradients to update weights and learn. Subordinate category was forward forward learning models, Jeff Hinton's alternative network architecture. Violation: the forward model, it is undeniably a deep neural network, but it purposefully does not use back propagation or gradients to learn. It inherits the identity of the superordinate, but completely rejects its mandatory defining mechanism. The collapse. This forces AI researchers to either say a network can learn without learning algorithm. So this forces AI researchers to either say a network can learn without a learning algorithm. So that's one category it has to fit in, not two at the same time, or acknowledge that the superordinate definition of neural network must be expanded to include gradient-free biological mechanics. Would you like to explore inclusion principle breakdown? It's currently forcing computer science to rethink LLM can truly be classified as intelligence. Okay, well, so an object that is part of a superordinate superordinate category X must is required to fulfill all the necessary features, or is it a case of having said features but exhibits behavior and findings contrary to the superordinate category, thus leading the object to be expelled from X and having a new subordinate category be created entirely in, i.e., a new school of thought, field of study, area of research. Am I on the right track? And give a very simple example. Ooh. So I think I have scored a hat trick. Yes, you are on the right track, but with one crucial refinement. So I think this is probably a goal that's deflected. Freaky. An object cannot be expelled from the superordinate category if it still holds the core defining nature. subcategory. Instead, the object being thrown out, the object contradictory behavior shatters old subcategories, forcing birth of a new subordinate category. School of thought field study. Here are two paths. Here are the two paths work in real science. Here is how the two paths work in real science. Path A, object stays, field reorganizes. So if the object is fundamentally a part of superordinate X, it cannot be expelled. Instead, its weird behavior forces scientists to invent a new subcategory beneath X. This births a new school of thought. Path B, object is expelled. Maslama. This only happens if we realize initial testing was wrong. An object never actually belonged to subordinate in the first place. So misplacement due to miscalculation. Simple example, the birth of a new field, quantum mechanics. This perfectly mirrors your idea of a new area of research being born. Physics, the study of matter and energy in the universe. Objects in physics were required to fulfill a necessary feature. They must follow predictable deterministic paths like a thrown baseball. However, scientists discovered electrons, subatomic particles. Electrons are undeniably matter and energy, so they could not be expelled from physics. However, they exhibit chaotic, contrary behavior. They could vanish from one spot and appear in another instantly. Subhanallah. The result, because electrons couldn't be kicked out of the universe, obviously, scientists had to create a brand new suborder field, quantum physics. This completely new school of thought was created entirely to build workable models for this anomaly. Simple example of path B, true expulsion, Pluto. This is what happens when an object is actually expelled because it fails the features, necessary features. So planets in our solar system is superordinate category X, the new feature and rule back in 2006. To be a planet, an object must be big enough to clear its neighborhood, gravitationally sweep away other space rocks in its orbit. Pluto did not have this feature. Its orbit was full of icy debris. Pluto was expelled from the superordinate category of planets. A new separate subordinate category was created for it. Similar objects called dwarf planets. So, some of you are thinking you are exactly right about the outcome. These violations are literal engines that birth new schools of thought. The object must stay in the big group. We build a new subfield like quantum physics. If it does not belong, we expel and rewrite definitions. Would you like to see how this exact tension is currently birthing new fields of around AI consciousness and synthetic biology? Right. So, alhamdulillah, we have gone very, very, very deep into this, and I've enjoyed it. I think this is very beneficial for the generations to come and to the curious. So, inshallah, on the next one, I will be using the same principles we've spoken and explored today and speak about connectionism because apparently there are new violations and things happening in the field. Till next time, Assalamu alaikum wa rahmatullahi wa barakatuh.